Hey guys, so we already did some live notes in class, and now I'm just going to go over the notes one more time just in case you had any extra questions. Okay, so we're talking about inequalities, very similar to equalities, right? But we have inequalities in front. So from a review, we have from the number line, which point is the correct for x equals 2? Well, if we're trying to find x equals 2, we want to find where 2 is on the number line. So obviously not -1, obviously not 0, obviously not 5. That is our x equals 2. That is the point that is on 2. So our definition of an equation, it has to contain an equal sign. All right. That has to be in something that is called an equation. If it has a different sign that you may or may not recognize, that is when it's called an inequality. So the mathematical sentence that uses an equality symbol to compare values of two expressions. So we have four main types of inequality symbols. All right, we have our 1, 2, 3, 4 right here. All right. Make that a little bigger for you guys. And these have different meanings, okay? Ultimately, we always assume that we are writing them something like this, right? So we have like x is less than 5, all right? So for here, for this guy, that's technically called our less than symbol. Where the next box would be considered our greater than. Great. All right. So we have greater than, and I'll draw lines of these because I did not make them too separated. We have greater than. All right, then the next one is very similar to the less than, right? But it's less than or equal to. And some of you might notice why it's that or equal to, and it's because of that line that's under it. That line is saying that we could have a number that is less than or equal to the total amount. And we'll show some examples of that. And the last one would be greater than or equal to. All right. So those are our four symbols, and we are going to identify those symbols doing different ways. All right. Now here's an example right here. We have this is considered x is less than 5. So you can put any number in that you could ever think of right here as long as it's less than 5 and it will hold true. Okay. So you can put 4.9 there, right? Because is 4.9, even though it's very close, 4.999, is that less than 5? Yes, that is still less than 5. And so that still holds true. All right. So that is one example. And we can use those symbols in different ways. So I can put, I could put 2x. But we won't go there yet. Undo. So I can do x is now going to be greater than or equal to 3. Okay. So in this statement, this is another inequality, but now x can be greater than, so it needs to be bigger or equal to 3. So it can be exactly 3, or it can be any number larger than 3. All right. So that makes it really nice. So we have one extra solution right there because 3 does equal 3. It's kind of like when you go into if there's 100 seats in a stadium, right, or in the theater. There's 100 seats in the theater. We can have exactly 100 people. We can have 99 people, but we can't have 101 people. And that's when your inequalities, you see them in real life, is in those kind of situations. So right down here, we're going to circle the inequalities. We're going to look through this. This is 3 equals x. That is not an inequality because it has an equal sign. There we go. We can have more than one number on both sides. This is just saying 9 is greater than 3 times a number. Okay, but that's still an inequality, and we'll talk about that. Over here, yes, that is still an inequality because it has an inequality sign. This is 5x equals 10. We do not want equals, so that is not an inequality. Right here, 6 is greater than or equal to 4. That is a true inequality, all right, because 6 is greater than 4, and then that is not an inequality, all right? So this is what Miss Neff was, this is what I talked about up here. We had them down here. I did not see that. We have the greater than and less than symbols, okay? So we have our less than symbol, and we have our greater than symbol. And down here we have our less than or equal to symbol, and we have our greater than or equal to symbol. Ultimately, we can, some of you guys might have seen these before. We can think of them always as like a Pac-Man, right? You can like make it a Pac-Man, or you can make it maybe like an alligator. But there's been different ways that people have taught them in the past. Basically, an inequality symbol always wants to eat the bigger portion. Okay, we always want it to be going towards the bigger number. All right, that's what makes it true. So if you can kind of always ask yourself, is it greater than or is it less than? Which one is it trying to eat? Okay, that might be able to help a little bit. We always like to read from left to right. So we would read this as x is greater than 3 because the sign is eating the 3. Okay, because again, our symbol, our greater than symbol wants to be eating the bigger number. And it's telling us that x is going to be the bigger number because we drew a Pac-Man there. It is eating it, right? It's eating it. That's a sloppy Pac-Man, but you got the point. The same expression but backwards is, so we could write it like this. 3 is less than x. All right. So even though these are the exact same thing, this one reads x is greater than 3. This one reads 3 is less than x. But either way, we are saying that x needs to be the bigger number. Because again, no matter which way we put this symbol, the Pac-Man still wants to eat the bigger number. It's facing this way on this equation. It's facing this way on this equation, but they're the exact same equation. We're just writing them on different sides. Okay, so we typically like to have the variable on the left side, though. It makes graphing a lot easier when we start graphing. So we want that on the left side. So whenever you're writing your own statements, always get in the habit of putting x first. So if we look down here, we want a number x is less than 8. So we have our number x. We don't know what x is. And we want that to be less than 8. Because 8 is going to be the larger number. X is less than. We do not want to eat the x. So we have 16. 16 is greater than. It wants greater. So it wants 16 to be greater than or equal to, okay, put the little line under it, than the number h. All right, so look at it. I'm just copying down exactly what the words are. A number p could be greater than. It could be greater than 2. All right, there we go. So that is a little bit of just the definitions and talking about it. The next thing we have is we have something called graphing inequalities. Yay. All right, so what we only have to do 2 things, and it's super simple, guys. Okay, so only when the variable is on the left side can we follow a special rule that makes highlighting super simple. All right, so when it's on the left side of the inequality, the arrow will match the inequality symbol. So notice that we are marked this 2 right here. That's where we got this 2 from right here. All right, that's where we got that 2. So that's where we put our first mark. Boom, 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 boom. Some people use, you can either fill that mark in or you can use a bracket, and we'll explain that. And x wants to be greater than. So we're going towards the greater numbers. But notice that this inequality symbol is also pointing. It looks like an arrow. Look at that. It looks like an arrow. And right here we have an arrow. So when your x is on the left side of the equation, you can actually use the symbol to show you which way it is pointing. That's just a little trick for the future. All right. So let's try a few of these. I'm going to do 4 and 5. and then you guys will practice the other two on your own. So the first thing we want to mark, we always want to mark is our 4. Okay, whatever number's here, -2, -7, 0. That's the first thing we mark. Now, if we go back up to here, all right, so we need to know that when we have a symbol like this or like this, when we write that on the graph, we are going to use an open circle, or we can use a parenthesis. Okay, when we have a symbol like this with the equal to sign under it, we need to use a closed circle showing that it's including the number that we're starting on, or a bracket. Okay, which is why up here where it was greater than or equal to, that we use the bracket or the filled in circle. You do not have to use both. You can choose. So on this one, I see I'm going to start at my 4. I know it's going to be an open circle. It's an open circle, or I could be using my parenthesis, okay? And I know that x is going to be less than. Look, it's pointing to the left. You see how it's pointing this way? It's pointing this way. So we know we're going to highlight all this way, okay? And you can always put a number in there. If I put the number in 2, is it true? Well, yeah, 2 is less than 4. Okay, so I want to highlight towards all the numbers towards that 2. Okay, same thing. If I put a 6 in there, is 6 less than 4? No. So we know that that way is not true. So you can always just pick a number and then find if it's true or not. I also could use a parenthesis here too. Boom. All right, this one, we have -2, so we're going to start right here. Is it open or closed? Okay, well, we have the line this time, so it's going to be a closed circle. Oops, -2. All right. And this time, again, we're pointing this way, right? We want x to be less than, so I'm going to put my bracket 2. You can choose which one you want to use. We prefer the bracket and the parentheses. There we go. All right, so we can go ahead and try these two. The last part you guys have is whether something is a solution that makes it true. So all we're going to do is we're going to take this 3 and we're plugging it into the equation. So I'm going to take 2 times 3. Well, is 2 times 3 less than or equal to 10? Okay. Well, 2 times 3 is 6. Is 6 less than or equal to 10? Yes, that is a true statement, so I need to mark true. That's called substitution. We've done that with equalities before. All right. Next one. Let's put 3 in for here. We have 3 times 3. Is that less than 9? Well, we know 3 times 3 is 9. So is 9 less than 9? No, that is a big old false, guys. All right. If, I'm going to put it in green, if there was a line right here, this would be a true statement because now it's 9 is less than or equal to 9, and 9 is equal to 9. Okay. So that's the big difference if that mark is right there. All right. So you guys kind of get the hang of this. We've done all of this before when there was equal sign there instead. All right. So you're doing the exact same math and you always carry down the symbol. So I can do one more actually. On this one, we'll draw our line going down. So we subtract our 1 from both sides. All right. So we're still trying to get the variable by itself. So we have 6x. Is the symbol always stays the same for now? Is greater than 20. All right. Then I'm going to go ahead and, 19. Sorry. I got to subtract 19. And then I'm going to divide both sides by 6. And then we get x is greater than, because the symbol stays the same. X is by itself. And we get, of course, a fraction. So I'm going to get my calculator out really quick. 19 divided by 6. And we got 3.1, 3.2. So x is greater than 3.2. So we could do that, and I can put in my 3, right? Is 3 bigger than 3.2? No, that's false, okay? Or I could have done the whole problem this way, just taking my 6. I did a little extra there. Sorry, guys. I'm substituting my 3 plus 1 is that equal to 20? This is obviously the faster way. I apologize. I forgot we were substituting. So 6 times 3, 6, 12, 18 plus 1 is 19. Is 19 greater than 20? No, that is false. So we put a big false there. False. All right. So you guys have the rest of this to do on your own. We obviously did this in class. It's just whether you need a little extra help. Let us know if you have questions.